And then I'm going to show you the main folder of Hive because I have a bunch of stuff that are interesting. Well, first of all, okay, you have there the binary of Hive. Hive is running as a service, okay? And we have different things. We have like the SQL Elite database where everything is literally, and then we have different folders. We have implants, we have staging, where we are gonna save or like creating implants, and inside that folder are gonna be the compile implant. It's gonna be also the Terraform plans, okay? Sorry? Oh yeah. Well, it's a video. I don't know if. Yeah, sorry. I did not think about that, but you are right. I don't think you may not see as much. That's okay. We're gonna play mainly with the graphical interface. I am running right now the process of Hive because I want to show that when you go to create an implant, the interface is what is. Do you see the bottom line? The interface of SiestaTime, more or less. Okay. So this is a form for crafting implants. Okay. So we just put the name. We can put the time to die. We can choose, this is the network module, right? So we can choose between the difference that I have already. The ones that are working already are HTTPS, Go Paranoid, and Gmail. So there we're gonna like pick up how the implant is gonna egress, literally. We will have in the future other like modules that we can pick up there, but right now I just HTTPS Go is the one is working. And now here we can just add. That's the different domains we have already like saving or like SiestaTime framework. And we can start to add as many as we can we like for creating the implant. So right now I'm gonna add 2 different ones. Each row is a VPC and a domain for this network module. That means that we can provide him different VPC server for like Amazon Azure, because it can be interesting if we want to have like 5 or 7 different credentials for Amazon or Azure, because we can make our implant to maybe egress to China, to US, or maybe use Azure and Cloudflare, whatever. There is like, we can put a lot of like diversity here in the implant, right? And domains, I'm gonna use my STTime 1, I think, or my STTime 7 and STTime 8. So we just click create, and what's gonna happen in the background, the job from the Electron UI is going to be sent to the client Go, and client Go is going to send to Hive. And now you're going to see, if you see, sorry, because I know it's very small, that Hive is going to start to compile everything. There is like at least 6 compile Go's going over there that start to compile the implant for the different platforms that I already have aware, right? And that is going to generate the binary inside Hive. Sorry, if you don't see the source code, you can check it later in the GitHub, but literally here this is the string of the plan Go. And when I send the job, Hive is gonna choose between the different options. I'm gonna feed in the strings differently to create the plan, okay? So this is a plan for AWS. We will have in the future plan for other like VPCs. We will see. And these are used the OS exec for compile Go. And I know, guys, what you're thinking, crafting a string in OS exec is literally a command injection. I need to fix all the security vulnerabilities, literally. So, okay, this is the cross compilation of Golang. We have the tags and we have the parameters. The parameters is the JSON configuration, because if we use a network module to use, you know, like ports and domains, we need some parameters. While if we are going to use Gmail, it will need like credential JSON and token JSON. So in this compilation, we're giving to the implant all the parameters, and the modules are the tags of Go that let us to compile some class versus others ones. So in that way, we can have modularity, right? So these are the platforms that are like compliant right now. We could do more maybe in the future. And you can see on the top that is all is using like Golang encoding for JSON. So everything is JSON in the tool. I use JSON encoding because, I mean, base64 is not enough for all the information I need to send to them. Also because I kind of know web technology, so it's easier for me. And this is the function that we generate the infrastructure. I was talking about the strings I am generating. There is a lot of comments for all the debugging I was doing recently. So now I'm going to show you, this is the register battery option of the graphical interface. Here we can like just add more credentials for different Amazon servers. Like right now Azure is not working, but for example, you choose Amazon AWS, we have there all the information we need for one instance of Amazon AWS, and we can choose the region, we can choose the AMI we're going to use, and everything. I have right now 2 created, and then the domain, similar way. Now I have GoDaddy and Gmail. We need to put the access key and everything for the domain, and for Gmail, similarly for the JSON and credentials. These are all the domains I have. You can see that the ones that say active, they're the one, they say no, that's the one that we can still use for creating new implants, because we have spent some domains. The graphical interface is going to detect that we have used them, so it will not let us to create implants with already working domains, because we are going to like kill all redirectors in that way, right? We have the Gmail. I'm going to add here, because I want to do a POC here, so my first Gmail account, these all are dummy Gmail account I have created just for the demo. The first one is not working intentionally, so now I'm going to just add, the credential JSON and token JSON. So you understand a little bit how this works. The connection with Gmail is a OAuth connection, right? So I just create my OAuth app in Gmail. I just get my credential JSON and token JSON, and with this, my implant and my redirector are going to be totally fine for egressing with it and sending all the payloads that I need. So I'm creating this domain. We will use this domain later. And here I'm showing a little bit how the Electron UI is sending the job to the client Go, and this is literally what we're going to pass to the Hive, and Hive is going to process all that data for add the domain, for example. Here is all the job logs and the error logs as well. This is very interesting for term of reporting, because everything we are doing right now, everything is getting like safe. So for generating the report later on, you are going to see that everything is safe. So I'm showing a little bit here. The database is used as SQL database, and everything you see there, Hive is using a connection just to like transfer all that on JSON and send all that JSON back to the graphical interface. So here we're going to see in a while that the implant is correctly created. You see, it took like a total of 5 minutes to create the implant. And there, in my Amazon account, I have the first redirector already created. I'm going to call him Red 1. And then in a different region, I have my next redirector already. I'm going to call him Red 2, because we're going to play with this when the implant is running, so you can see that it's correctly like performing, right? Okay, this one is finished. Let's go to the stagings. Okay, so we have seen we can create implants, but stagings are very important because they will let us like do things like, for example, dropping our implants, but also interacting with our session like faster. So right now I have used like 3 staging servers that works. The Droplet, that is an Apache with Let's Encrypt HTTPS certificate. I have the Empire Handler with HTTPS Let's Encrypt certificate. I have Metasploit as well. We're going to create a Droplet, and we're going to create an Empire, and we're going to create a Metasploit. But unfortunately, like Empire, Metasploit, all the shell scripting to the load, all like the dependencies take a time. Similarly here, we need to choose a domain and a VPC for the Droplet. We will put the port, and we'll put the path for like dropping our own implant, and we just create the staging. And then similarly with Empire, we choose Empire, we put the port, and we just create it. And in a time, I will say that in 5 or 6 minutes, we'll see the staging number here like increasing to like the number we created once it finished to deploy. Again, I'm showing the job. I showed this before, so let's go a little bit ahead. I want to start to showing a little bit of things. So here in the source code, literally Hive received that option, right? Received like, okay, create me that Droplet. And this is all the shell scripting that I'm just doing for installing the Apache, to like signing the certificate with like Let's Encrypt. That's the Empire, that is just like creating all the dependency. I'm going to show you things because what I have been telling that the stagings are running as a service Empire and Metasploit and also like tunneling, we're going to see all that a little bit in internals as well. So let's see which one is our Droplet. I think it's this one. That is the Empire. Okay, we will interact with this later, and that's the Droplet, right? Perfect. So let's see. Let's go ahead a little bit. Yeah, I'm showing here why the domains they are now not active, because we have used them for like the Empire and the Droplet and everything. Okay. So let's go to the Droplet. Here I'm showing a little bit how the staging folder works, and this is similar to the implants. We do see the hi-hat receipt to create a staging. This is the DEFCON Empire that I have just created. It has inside just the Terraform binary, the plan for deploying the redirector, the keys, and all the service that I am installing in the target staging server. This is the plan of Terraform that my Hive has created, and there is with all the parameters, the keys, and everything. So now I'm checking if the droplet is working. It's still not, so I'm going to advance a little bit. Let's see when it's prepared. Okay, I think now it's going to appear. It takes a time. Now we have the droplet already created. So now in the job log say that it's created, it's successful, so just like refresh, and we have here the droplet. So this is all automatic. The operator doesn't need to know all this process. I'm showing you guys. So now we need to check which is the path, because in that path we can drop all the implants we have created. So let's just check which is the right path. I'm checking. The interesting is not the path we grow when we create the staging, right? So we are going to put like now DEFCON. That is the one that we have in the parameters there. DEFCON 27. And it will be the right path for dropping our implants. We can change this. This is just because if we want to put a long hash to like hide our implants and anyone is just like messing with them, right? And we will now drop the implant we just created before. So we go to implants. We check what kind of attack we want to perform. Right now, it's just working drop implant. Obviously, I say HTA because in the future, we may like to automatize the creation of HTA for like dropping somewhere. We choose the architecture, we choose the operating system, put the name for the file we want to like use. We perform the attack. And then in a while, once we see in the job logs that is successful, we will have our drop implant in the staging server. So now we can just we can just send a phishing email or whatever and combine someone to download the implant installing somehow. It's a very basic attack, but it's one of the most basic ones that the red teamers could use. So now in the video, I just advance it because Empire is taking a time. I want to show the Empire right now. Okay, so now we have working the Empire. I'm going to show you how we can connect through the operator. So we just go to the handlers. On the staging server, we have list or Empire over there. We just interact with it. And client go, and that's the reason why I have a client go, because I can do like this. I can just open a num terminal, and we have over there the Empire handler. We can just like go ahead and interact with anything that is dropping on that Empire handler. And remember, we are in our like operator device. We don't interact with the staging at all. We just click a button from the graphical interface. We have our Empire shell from num. This is using Reptir over a process that is running in the staging server. And now in the end of the video, you start to create the Metasploit. But I just got this video because Metasploit take a time to create. So I just go to the next one and show you that the Metasploit is working as well. We have 3 staging here because I have the Metasploit already created. And it works, as you can see, with ST times 3, I think, 9. So then I just go to the handlers, go to the Metasploit, and just interact, and I have the Metasploit handler over there. The same as Empire, just clicking a button, I have the num shell, and the Metasploit working already. As a service in a staging server that I can kill whatever I want to kill it. I'm doing a little bit of internals here, so just show you a little bit what's going on inside the staging server. So I'm going to SSH into the Empire. I'm going to show you the service I created for it. Let's see if you can see it more or less. Okay, so that one is the service. It's literally the Metasploit handler running as a service, and everything that is being typed in the handler is saving in a log file. And we will use it later on for the reporting. So if you don't see very well, but it's just like the command for running the Empire handler. It's not anything else. And then I'm going to Hive because I have another service that is with the remote tunneling with the staging, so the operators can connect to it. Wait a minute. It's here. Okay, so in Hive, each time we create a staging, Hive is going to create a self-service in Hive, and the name of the service is going to be the staging name, and it's just doing remote tunneling to the staging and opening a new port on Hive, so operators can just connect to Hive and interact with the staging in invisible way without interacting directly with the staging server. Okay, so let's go to the fun part, the implants, okay? Let's test first the implant we did create before. Because, okay, you are saying, okay, you have been telling all the features, but we want to see how the shells came back, right? So remember, we have the droplet, we have the Empire, we have the Metasploit. So now let's run a one-liner into like this Linux box. And with this one-liner that is literally just downloading the implant, giving like execution permissions and executing it, I just like will let Bichito run. And this is in the debugging mode. If you can see, sorry for the letter again, but there is literally we can see that the implant is starting the flow. He's just like reaching back the first redirector. The first redirector is STTime 7, and we see the authentication header is literally the implant ID or that process implant ID and the token that we generate on the creation of the implant. And this way we can check for relying attacks and all that. So our implant is kind of more or less secure. We're gonna see that we just got one Bichito there. And then we just go to the ID that is correspond to the infection. We have all the checking information, and we have also the redirector that is attached to that infectation. And we can do here different things now, right? We have the interact button that is an extern that is sending jobs to Hive, and this is the job console I was talking about. Right now I just have exec that is just running a shell into the implant, which will change that in the future, but that's the modularity of the tool, right? We send the job, we receive it. But I want to show you guys more interesting thing. So, you know, we can send jobs, we receive it, that will be logged in the Hive, but we want to do post-exploitation, right? So we just open our like Empire handler, we go to our Bichito, and we say, okay, I want to inject a shell. So let's just inject Empire. And this is working through the redirectors, okay? I send the job, let's inject Empire, I am the same user interface, and I just wait. And without directly interacting with the staging, I do receive the Empire shell, and I can just do my post-exploitation session as much as I like without problems. When I finish with the post-exploitation session, I can just kill the staging, and that's okay to go. If the blue team say, okay, this server was doing weird thing, it already doesn't exist anymore. But my implant is still silent on the machine. This is like the log for the normal jobs that we can send to the Bichitos. And I am testing now. You see my redirector, I'm gonna kill it and see how the implant is transparently swapping from like the first redirector to the second one I did create for the implant. And it's gonna continue working transparently. Here the regular is saying, where is my redirector? Where is my redirector? At least 4 times, and now it's swapping to the next redirector. And I can still work with it. Sending jobs is going to work without problem because it still have a redirector attached that you see it has changed to STTime 8 when it was STTime 7 before. And now let's go to a little bit what I think that is the meat of the talk. We are going to do the same, but using Gmail. And particularly, we're going to use Gmail draft for doing the same, okay? So literally, give me one string, and you will be my redirectors. So every company around there, if it provides you a string, you can use egress with it, okay? So this is another implant that I did create before because I was not to spend all the time for creating another implant, right? So we have here Gmail, DEFCON Gmail is literally using 2 accounts. Gmail, the one that we add with the credential JSON and token JSON, another one. It's gonna just be checking out with the first Gmail account. We can see the same, we put their own aligner, it's gonna download the binary, it's gonna execute it, but instead of connecting with HTTPS to the redirector and my domain, it's literally sending emails to Gmail. Okay, that's the subject of the email that he's sending. And if we go to the email account, we can check that in draft. we have just the draft, the subject is the ID of the implant, and the body will be the JSON where we send the payloads. And what the blue thing is going to see? Oh, my employee is connecting to Gmail. Nice. So I think that this could be silent. This is just a model of a lot we can create. And I'm going to do the same that I did with HTTPS Go. I'm going to just interact with it. I'm going to type some commands in the command line of SiestaTime. And I'm going to interact and send my Empire shell. And everything is working through Gmail. Don't forget about that. And it's totally transparent for the operator again. So let's interact with it. Let's get our Empire again. And let's just inject the Empire shell. We have seen this already. So let's go. So let's inject it. We choose the staging server we want to use for the injection. And this is just a launch. It's not a real injection yet, but we can change that with the modules. So here we are going to reserve our staging through Gmail. Here we receive the shell. The implant is still running using Gmail, but we are like just processing our post-exploitation session with the staging server. I am going to go back to the Gmail account so you see what's going on there, right? We can see in the subject, that's just JSON. That is just sending through, the implant is sending back to the the implant is sending this to Gmail. The redirector we have deployed is connecting to the Gmail as well, and then the redirector is sending back the job to Hive. So these are only two hops from the implant to the Hive. So they could like maybe cancel the out for that Gmail account, but they still will be working with the next Gmail account we can provide. And I am not using a crazy technology. Use the Gmail APIs that Google is providing for, like, you know, querying the draft and modifying the draft. So yeah, these are the implants. Persistence, unfortunately, I don't have it yet. But let's go with the important part that we all love, right? The reporting thing. We forgot about this, but let's make clear, like, this is the most important for the blue team. And it's important that everything we're doing, we're reporting it. And we're like recording it. We need to know what we have done, right? So I'm going to show the last video, but I think is maybe the most important one, and is the shorter. So let's go to the reporting. We have done a lot of things. We have created implants. We have created droplets. We have sent command. We have interacted with two shells. We have like add new domains. We have done a lot of things. So let's just create a report. Hive is going to receive this job. It's going to timestamp what we are doing. And once the report is created, we can just download it. And right now it's very primitive strings, but in the future we may create a more clean report with XML or something so we can see things better. So now I create the report. I'm going to list that report. That is called Blue Team Help. We download the report, and it will like download directly to the folder of the operator, and we can just like watch it. And it's not very organized right now, but those are all the commands we have been sending to Hive. It's per user basic. And most importantly, we have all the interactive shell over there that is per user basic as well. So for every interactive session we have, we can see what we have been doing. Everything is recorded in reports. Okay?
I have a question for you.
Yeah.
As far as exfiltration, maybe I missed it, but I saw you did some things with Gmail.
Yeah.
What about, like, where do you store it? Is it always in, like what are the options as far as storing download files, size limitations, things like that?
So you say for exfiltrate data from the internal company outside, right?
Correct.
For the moment, I don't have modules targeting exfiltration, but we can create a new staging server that instead of being called Empire, Handler, or like Droplet, which will call himself exfiltration. I was thinking about that. Why not use Facebook or Instagram for like doing stenography over image and then exfiltrate everything? We could add a new staging for doing that. I just need the help for the commit to the GitHub because there is a lot of work there, right? But we can do it, and we could have this framework for doing everything, right?
What kind of commands can you execute with the Gmail? Like what kind of command control?
So the API, I think it lets you to do most of the things. Like I did choose draft because I did not want my implant erroneously like sending an email or something like that. That would be really fun, right? And draft are kind of the same as message, but they just keep static there. And if you don't call Gmail send, the information is going to stay there. But maybe Gmail is providing you more APIs that I don't know that could do like more interesting thing. I mean, right now the fact you are using Gmail in terms of network aggression, the blue team is gonna just see that there is a computer that is connecting to a Gmail. And if they do deep packet inspection, okay, they do deep packet inspection, they are gonna see how many Gmail from the company. Maybe they can query now Bichito's thing. That's the reason why Bichito is made. Now they can detect Bichito by maybe querying that string. But we can create a new module that uses Gmail, but in a different way, right? And then Blue Team will detect with our first implant, but the second one that we just have, maybe not. We can, as a red team, we can use a new very cool thing. We can have successful operation, help our blue team to detect, but then we can help the rest of the blue teams to detect that as well. We don't need to be selfish on our operation, right? That's how security industry works. So future work, I mean, this is a very baby project, has a tons of bugs, tons of security vulnerabilities. I need to fix a lot of them. But you know, the more things we have, the more strength we can give to the framework. I have think a lot of things to like add in the future, obfuscation, new like kill chain attacks. I mean, using Google Analytics to egress, it will be cool, right? Like how many embed devices use Google Analytics? And how many string Google Analytics is providing to us? We can perfectly egress with it. It's just, I need to study the API, that's all. A lot of things to do, and I really ask for help here. That's everything. Thank you so much for making this possible and make part of DEF CON. This is more than a talk to like show what I have done. It's more a talk for like call for commits. I would really like people to like come into the GitHub, say me, Alvaro, you know, like this cool new module could be added. Let's do this tool, amazing, right? Let's use it all together. And let's not forget that this, even if it looks very offensive, is for helping the blue team because it's our last thing to do, right? It's the most important thing to do and the last thing that we finish in doing. That's everything, that's the repository, everything is up, and question time. I'm going to post the slides. The video, I think, is going to be posted as well. I will use my GitHub account, my Twitter, everything is going to be online. And the tool is already ready to use, has a lot of bugs, but you can use it and see, you know, you see something that is really horrible, we can fix it.
Can you control the domains that are created, or is it always like random, you know, .xyz type domains?
You can add your domains, totally. You can add how many domains you like. That's
the name of the domain.
Well, when you register a domain, you are kind of using that, right? You can. I have still not added subdomains to it, but because I have not seen as many potential internal like silent, because when you use a domain, they block that domain chain, and then all the subdomains will go ahead, right? But we could use that. Everything you think that could be added, we can do it. Right now, it's just adding your domain, and that's all with your credential. You can change the IP for that domain. But we could think about new models for domains, with new different ones, right?
Thank you.
Yeah, you're welcome.
How come you went with Electron instead of just a web app or just a usual browser interface?
I did choose Electron because I wanted to be cross-platform, kind of. Right now, it's just working on Linux, but also like I wanted. I know that with a normal web page can be cross-platform as well, but I don't know. I like it to do things like the thing I did. Like I can click a button, and then I could like it's true. I could do that in the same way with a web browser. I don't know. I choose Electron because I wanted to learn about that technology as well, and I think it looks nice too. But everything I think can be perfectly made without just web browser. I don't know, use a technology decision. We can swap that. It's just like HTML, CSS, we can use like change that to a browser. In fact, we can even create a new like user interface that uses a browser. There is no, we just like need to send and receive information from the client go. So, yeah. Thank you for the idea.
I was just curious because if you had a particular reason for a particular library running that needed Electron.
No, we can do perfectly with web technologies, everything, yeah. I don't feel there is a blocker for that. No.
What other control channels have you thought about using other than what you have so far?
Well, all the ones that exist already, but I have not like spending as much time with things like TCP/IP because, I mean, it have a lot of like I mean, there is a lot of libraries with TCP IP. I'm not gonna do better than them, but also because I do feel that most of the aggression nowadays is done through the HTTPS. So I say, okay, I start with HTTPS right away, and the next network module I'm gonna create is gonna be like one step ahead that I do feel is using like software as a service, right? So every software as a service that you can imagine, we can use it.
I was more like talking how you use a Gmail draft with the APIs that you controls like those. You know, if you're thinking like Slack and
We can use Slack perfectly.
on a, you know, just a private workspace, using things that would not
Everything.
block enterprise.
Well, we can use not enterprising. I mean, everything will give you a string. I thought about Gmail for one simple reason, because I did not have as much time. I was using Go, and the Gmail API is amazing. You can do a lot of things through Go. Sorry?
So not a lot of people blocking it.
Oh, yeah, exactly. Also for Tenos silent, but Slack could work as well. Like, again, every company or software as a service that give you for free the ability to like interact with it and pass it a string, it will be working for aggression. You will need to think a little bit better how you are doing it, but it's perfectly like.
You just need a place to
Yeah, you need a place just to put information. Yeah.
just JSON.
Can be in images too. I was thinking about Instagram. How cool will be like just uploading, you know, the same photo of David Hasselhoff like in Instagram.
Anything that's
Yeah.
popular and has a good API.
Exactly. That's the idea. And we can like work on it. Like I definitely I'm gonna be supporting this tool as much as I can and trying to get it better. Now I'm gonna focus a lot in bug fixing because I mean everything works, but like sometimes the implant do something weird, and the implant is very important at worst code because if the implant fails, what's this about, right? So yeah.
Are you gonna slowly roll off Empire since they're ending support for that?
Yeah, I would want to talk about that. Like, I mean, ideally I should create my own like interactive console, right? But it's a lot of job. It's a lot of low-level things that it still doesn't know. Like I know like basic Windows API, maybe OS X. Yesterday they did a very good talk about Swift. We could like use that source code to create our like Swift implant and just use the Golang Swift library to do it. If it exists, I think yes. So yeah, like the implant requires a lot of heads or like system programming, and I would love to have those people working on it to like having this, right? And now the modules that they run jobs, they're very simple. They're just calling Golang OSSEC, and any simple ADR is gonna detect that. But if we change OSSEC for like the real, you know, Windows or like OS X APIs or Linux API for like just listing for LS, instead of like calling LS in the shell, we just create our own LS, copying some source code that is around there. And EDR we need to do better because the most we blending with the rest of the software in the computer, the better, right? So that's the objective. But having this already made is useful because if the blue team wants us to be detected, we just like swap the implant. We choose this one that is the first one, and they will detect it. And we're like, oh, we detect something. That's nice, right? So yeah. Good.
If there's no other questions,
Thank you.